Good morning. Welcome to today's webinar entitled Reducing Occupational Risk of Heat-Related Illnesses. My name is Dane Sprankle. I'm a health consultant with the PA OSHA Consultation program, and I'll be presenting the information today. Some general information about the format of the webinar. For questions, they can be submitted through chat. Keep in mind that some questions may require a more thorough response from our program, and for those types of questions, we will post them along with the answers within 7 days following the webinar today. They will be posted on our website, and the webinar recording as well as the PowerPoint will be posted by tomorrow. With regard to questions, we would prefer that they are addressed or targeted toward the topic of today. We do have consultants available to answer other OSHA-related questions, but we would prefer that questions today are directly related to our topic. And just one note on the subject of occupational heat-related illness prevention, why we're covering it in April. It's probably maybe seems a little bit early, but we would prefer to go over it now before we start to get into the hotter months of the year. I know there's days this time of year where summer and hot weather are the last things we're thinking about, but we are probably not as far away from hot weather as I think a lot of us are feeling currently. So to start off, just to go over the main types of heat-related illnesses that we're talking about in order from least severe to most severe: heat rash, heat cramps, heat exhaustion, and heat stroke. Heat rash is pretty much what the name implies. It's a rash due to high heat exposure along with significant sweat. It's obviously not one that is going to be life-threatening, but it's not comfortable either. Some people refer to it as prickly heat. Moving up to the next level of severity, heat cramps. That's basically muscle cramps that occur during high heat, as well as typically higher levels of exertion, and the cause is generally a loss of fluid and body salts where the muscles aren't able to recover. And it could occur obviously during the workday, but it also could occur in the evening or shortly after work. So that's something that in your training program, you would want to make sure employees are aware that something like that could happen following the workday. The next level of severity is heat exhaustion, and this one and heat stroke obviously are the two that are where it becomes more of a serious situation. Heat exhaustion, similar to heat cramps, is due to loss of water and salt, and it's associated with very heavy sweating. Symptoms include headache, nausea, dizziness, general weakness, irritability, and thirst. And the most severe heat illness is heat stroke. It's a medical emergency, and basically the body can no longer control or regulate core temperature. Sweating stops, skin becomes dry, and it is very, very serious situation that has taken many lives over the years. So it's not one to play around with. And we'll talk in more detail later on about first aid for each type of heat illness that we just covered. This it may be a little small to be able to read all the information here, but it's just a general table that shows the symptoms and first aid for each type of heat illness, starting at the top with heat stroke and down to heat rash. Again, we'll go over the first aid issues further on in the presentation, but the symptoms there, again, that's something that you should be well informed about, and your employees should as well, so that they know what to look for in themselves and their coworkers. What are the risk factors for heat-related illnesses? There's quite a few. Today, we're only going to really focus on the most common ones and the ones that are most controllable. But just going around the circle here, starting at the top, obviously high temperature and humidity. Direct sun exposure is a significant contributor. For indoor workers, radiant heat sources like in a steel mill, for example, or maybe in a power plant where you have boilers. Limited air movement obviously would contribute to potentially heat-related illnesses. Not enough fluids, high physical exertion, PPE and clothing. It's kind of a double-edged sword, of course, with PPE. It's there to protect you from one hazard, but in high heat environments, it can actually contribute to the heat-related illnesses. So you have to really evaluate what's out there in those situations that can protect the employee without adding a new hazard. Physical condition and health of the employee is a big factor. Medications can be a factor. Pregnancy, again, that can obviously be a factor in a heat-related illness. Lack of recent exposure, typically that's going to fall under the acclimatization aspect, and we'll talk in a little bit, or actually a lot more detail about acclimatization further down in the presentation. Advanced age can be a factor, and previous heat-related illnesses can also be a factor. So the 5 that I want to focus on today are occupational, environmental, work activity, clothing and PPE requirements, and acclimatization level of the employees. So obviously there are certain occupations where the risk of heat-related illnesses are higher. For indoor work occupations, examples, foundries, electrical generation. I know we already talked about these a little bit. Bakeries and commercial kitchens, laundries, some chemical plants. I'm sure there's a lot of others. But in the pictures there, you can see the steel mill and the laundry, commercial laundry. Those types of environments, due to the nature of what they're doing, clearly could create a situation where there's a higher risk of a heat-related illness. For outdoor work occupations, any type of construction, and that would include utilities, oil and gas operations, farm work, landscaping, emergency response occupations. And again, I'm sure there's a host of other outdoor occupations where there's a significant risk of heat-related illness. But generally, common sense will be your guide when you, in terms of what work environments would be more likely to be at higher risk of a heat-related illness. So the pictures there just, again, show examples of work environments where typically you may see those types of issues happen. Environmental risk factors. The first one, and probably the most important, is the heat index. Heat index is a combination of temperature and humidity. It combines the two into one number, gives you the quote unquote real feel temperature. So if you look at the left, the various levels of heat index, and there's different scales that are used, but they're all similar to the one illustrated here. Levels ranging from low level up to very high or extreme. and the protective measures, and we'll talk about that a little later, but this was more to show you the different ranges or different categories of risk based on heat index. And this is another table just showing probably a little bit more detail on the various levels of heat index or the risk as associated with various levels. Take note, the comment on the right that the table was based on a shady work location with light wind and with direct sun exposure and no air movement. Those numbers are significantly different, or the risk level, I should say. So direct sun exposure, various estimates exist on how much it adds to your heat index, but most agree that it could increase it by up to 15 degrees from the typical category shown prior. So if we go back to this slide, for example, if the heat index at the lower level is listed at 91 degrees or less than 91, and you add 15 degrees to that for direct sun exposure, you're up into the moderate level just by adding direct sun exposure to that. And basically, for every category, when you add direct sun exposure, you're moving from where you are without sun up to the next level, from low to moderate, from moderate to high, and from high to very high. So it's a significant contributor, and it's something that absolutely needs to be considered when looking at the overall heat exposure for the workers. And then another environmental risk factor is air movement, of course. If there's no air movement, in most cases, that adds additional heat stress because you don't have the evaporative effect, and the body's natural cooling mechanism does not function ideally because sweat is not evaporating. The next risk factor is work activity. And again, there's a lot of different categories or different classifications, but most of them are similar to what I have shown here. Categories ranging from rest up to very heavy work, and examples on the right of each category. So, common sense, again, I think in a lot of cases will let you know if it's hard work or medium or light work, depending on what the employees are doing. But this, in general, these examples show you what would be looked at if you were trying to calculate an actual heat load on the work site. Another risk factor is clothing and PPE requirements. Some jobs require protective clothing that could actually contribute to the heat stress level of the employees. Examples of that type of PPE would include FR clothing that firefighters or even electrical workers may be required to wear. Disposable coveralls for maybe agricultural workers or people working in landscaping. Any double or multiple layer fabric. Respirators, full face in particular, could contribute to heat stress. Rubber protective gear for high voltage electrical work, or even maybe some low voltage electrical work. Rubber gloves, rubber sleeves. Obviously, those types of clothing or protective gear would hold in the heat. And as far as types of fabrics, the biggest factor that the science has shown is the thickness. It's not the type of fabric. So when you have double and triple layers of clothing or a fabric that may have 2 layers built into it. That's more critical than what it's actually made out of as far as retention of heat. Another risk factor, and probably one of the biggest, is level of acclimatization of the workers. In general terms, acclimatization is basically the body adjusting to a new climate, whether it be a hotter or a colder climate, but we're obviously talking today about adjusting to a hotter climate. And it's important because the body does not, once it adjusts, then it's biologically able to contend with higher humidity, higher temperature, to go from a normal work environment into a much hotter environment, especially if there's heavy work involved or heavy strenuous type work activity. The body just not ready for that without working into that slowly. And just as an example of why this is so important, there was a study in 2005 in California, and they found that 46%, which, roughly half the cases of reported heat illnesses happened on the employee's first day on the job. And 80% of the cases happened within the first 4 days. And in both situations, you're talking about employees that haven't had an opportunity to adjust to the environment. So that illustrates how important acclimatization is. Moving on to standards that exist for occupational exposure to heat. OSHA does not have a specific heat standard in place. The general duty clause is the current standard that would be used for citations regarding heat illness. Essentially, it says that the employer needs to provide a workplace free of recognized hazards that may cause or are causing injuries or death. And the key word there is recognized hazards, and heat illnesses are a recognized hazard. So, it's something that does need to be addressed for environments and work, different occupations where there is a risk for those types of illnesses to occur. As far as specific OSHA standards that address in one way or another potential heat-related illnesses, the personal protective equipment standard, which is 1910.132 for general industry and 1926.28 for construction, requires a written assessment of required or necessary PPE be conducted. So that standard would require that you evaluate the work environment for PPE, and it has to be a written and certified document. For potable water, requirements fall under general industry 1910.141, and under construction is 1926.51. And that obviously would be part of your heat stress program. Medical services and first aid are addressed through 1910.151 for general industry and 1926.50 for construction. And again, for particularly remote work environments, those issues have to be addressed. Medical provisions for first aid on the job and notification of advanced medical care. And construction also has a safety training and education requirement under 1926.21 that would also impact or potentially be considered a portion of the requirements to have a heat prevention, heat illness prevention program. NIOSH also has a criteria document that includes a lot of information addressing the a recommendation for a standard addressing occupational exposure to heat in hot environments. And the link for it is at the bottom there. But it's a lengthy document, but it does provide a lot of good information. And it's not something that is directly enforceable by OSHA, but it does provide information that would go hand in hand with the other recommendations that we've talked about, and provide you with good examples of different work environments and what options may be available to reduce the risk of heat-related illness. And another agency that has a standard or recommendation is the ACGIH, which is the American Conference of Governmental Industrial Hygienists. They have threshold limit values, which basically put a number on what is considered a risk level for a particular work environment. And they look at heat stress and strain versus only heat stress. And their standards are based on the wet bulb globe temperature as opposed to the heat index alone, which does take into account direct sunlight. It incorporates all the elements of heat into one number, and it's measured with a wet bulb globe thermometer. And there's a clothing adjustment factor applied. Now that, again, it's a recommended standard, and it's one that a lot of companies may use to try to come up with a specific number for a given work environment. But it's beyond, for the scope of today's visit or today's presentation, I'm not going to go into any more detail than that, but it is there are specific standards out there that can be reviewed and possibly utilized in a work environment. All right, moving on. Prevention. The prevention strategies basically fall in four main categories: engineering controls, work practice controls, personal protective equipment, and training. Engineering controls, more options for indoor work environments, but there are some engineering recommendations for outdoor work environments as well. Indoor environments, or even heavy equipment that's used in outdoor environments, air conditioning in workrooms, operator cabs, general ventilation, cooling fans located near the work area blowing directly on the employees, reflective shielding, typically for radiant type heat, like in a steel mill, for example. Insulation, again, to minimize radiant heat, and that would be like for example, on a boiler in a power plant. Portable shade, and this one would be appropriate and useful for outdoor environments. For example, the picture with the tractor with a shade, an umbrella built above the operator. Portable shade tents that could be put up for employees that maybe work in direct sunlight for when they're taking their breaks, or if they're on a work rest cycle where they can sit to get out of direct sunlight. Those are affordable, and they can significantly reduce the heat exposure. Work practice controls, emergency planning. That one, again, the OSHA does have a specific standard, but that's first aid training, first aid supplies. That's means of communication for the workers, especially in remote work locations. For acclimatization, very important, as I said earlier. Typically, you're looking at 7 to 14 days for most people to adjust to a new work environment. For new workers or workers that have maybe been off for an extended amount of time, the recommendation there, and this is an example. There are various other versions, but most of them are similar to what you'll see here. Recommend a 20% workload on the first day, and then the maximum increase of 20% for each additional day until they're acclimatized up to that 100% workload. For cases where there's a rapid or a significant increase in the heat index, like for example, if in July, if we have a heat wave or something that begins within a day or two from normal summer temperatures, you want to look at roughly a 50% workload on the first day, and then maybe add 10 or 20% per day after that until the employees have adjusted to that heat wave. Additional work practice controls, potable drinking water. That's a very important, probably it's right up there with the acclimatization in terms of importance. Recommendation is 4 to 6 cups of 8-ounce cups of water during the hottest parts of the workday. And thirst is not the indicator, or should not be relied on as an indicator to drink. The employees, as part of your training, and we'll talk about this a little bit later, but they need to be trained that don't rely on thirst, that whether you're thirsty or not, you need to drink water. The temperature of the water should be between 50 and 60 degrees. And obviously avoid drinks containing alcohol, but also avoid drinks containing sugar or caffeine. And also look at if you have contracted workers like flaggers or other contracted workers at the work site, not just for the drinking water requirements, but for your overall heat safety program. Another work practice control is using work rest cycles, where an employee would, if they have multiple duties to do in a given day, some maybe are heavy exertion, moderate exertion, and light exertion, to rotate those three throughout the day rather than doing all the heavy work at one time. Early and late day work scheduling is a common approach when it's permitted. There could be issues with noise ordinances and things like that, starting too early if it's construction work or something that creates a lot of noise. But where it can be done, starting a few hours early, or doing work in the evening during particularly hot stretches, that's a very good control. Worker rotation, where employees would just take turns doing the more strenuous jobs, or the jobs that are located in direct sunlight, or where there's a higher risk of a heat-related illness. Another work practice, and this would be for more extreme conditions, where actual physiological monitoring of heart rate, body temperature, blood pressure, breathing rate, etc. And again, that if the environment is such that's required, then that's something you really need to be properly trained in how to do those types of readings, obviously. Personal protective equipment as a control. It's limited, as I said earlier, particularly when it comes to outdoor work environments. But some examples: reflective clothing or face shields if there's radiant heat, self-contained cooling vest. That's kind of borderline whether that would fall under PPE or not, but there are vests and various cooling garments available. I'm sure they're not cheap, but they may be necessary, or at least may be recommended in certain work environments. Training is a control. This is something that should be done for all workers that are potentially going to be working in the environments where their risk is there for a heat-related illness. The training should address the risk factors for heat-related illnesses. It should obviously address what are heat illnesses, what are the signs, what are the symptoms, how to recognize those signs and symptoms in coworkers. That's very important because a lot of times they may not be aware that they're exhibiting symptoms of a heat illness. Training should also cover the prevention policies and procedures that the company has in place. And obviously the importance of drinking water, we talked about that already, the importance of acclimatization. Sometimes you have to protect people from themselves, so you want to make sure that even if somebody thinks they're in good shape and they want to go 100% right away, that make sure they're aware of the risk and what you anticipate or expect them to do to gradually acclimatize to the work environment. The importance of immediately reporting signs and symptoms needs to be stressed during the training as well, not especially when you start talking about heat exhaustion and heat stroke, because it's kind of like a runaway train, especially heat stroke, where once it gets that far, it's very, very dangerous, and it's something that is tough to control once it gets that far. First aid procedures need to be addressed as part of your training. And EMS notification, and it's important, I think I said earlier, how are we going to communicate? Do we have cell phones? Do we have two-way radios? And providing clear directions to the work site, especially for remote work locations. If you're out in the middle of a field somewhere, you really need to make sure the employees know how to communicate that, whether it's going to be by GPS coordinates or if you're going to have an employee stationed out at the road to wait for the ambulance to show up, you need to plan that out and include that in your training. This table is just kind of a nice encapsulation of the various risk levels of heat index and what your plan element or which plan elements apply. And so starting at the top row, the supplies and provisions, including water, apply in all risk levels, all heat index risk levels. For emergency planning, again, that applies across the board for all the different risk levels. Worker acclimatization, again, applies for all 4 risk levels. Modified work schedules typically would not be necessary for the lower level, but it would apply for the moderate, high, and very high risk levels. Training definitely applies across any risk level for heat illness. And the bottom row, the physiological, visual, and verbal monitoring, that would typically be your moderate, high, and very high. Keep in mind, again, that those heat index risk levels are somewhat subjective, and if there's direct sunlight, if there's no air movement, normally you're going to want to bump, even if you're looking at the heat index itself, you're going to want to bump them up to the next level at a minimum in considering what protective measures and what plan elements would apply. Moving into the first aid, and this is real general for employees where that are part of your plan, as well as the employers. You should really go through a formal first aid course, and for not just for heat illness, but for general first aid. And for work environments where you're not considered in near proximity to advanced medical care, it's a requirement that you have a trained person on site in first aid. So I'm just going to go over the general recommendations for each level of heat illness, but keep in mind this is not a be-all end-all first aid course on heat index or heat illness response. So for heat rash, pretty simple. Stay in a cooler and less humid environment if possible. Keep affected area dry. Heat cramps, the worker should be put in a shady area, allowed to cool down, drink a lot of water, rest, and just hopefully the cramps go away. If they don't, though, within, say, an hour or a couple hours at the latest, they should seek medical attention. For heat exhaustion, now we're getting into the more serious heat illnesses. They need to sit down or lie down in a cool, shady area. Again, plenty of water, cool with ice packs, cold compresses, which is something you need to make sure you have in your first aid supplies. They should be taken for evaluation if their symptoms don't improve within an hour, and they should not be returning to work that day. For heat stroke, this is immediately dial or contact 911 using whatever your communications policy has determined. Worker needs to be put in a cool, shady area, loosen clothing, remove outer clothing, provide fan or even just a hand fan if need be, cold packs and armpits, wet the worker down, cool compresses, provide fluids, and stay with the worker, obviously, until advanced help has arrived. But again, it's a medical emergency, and it's something that you can't waste any time with. Additional resources for help with preparing and maintaining your heat illness prevention program. The OSHA website, the link there, a lot of good information. A lot of the information in this PowerPoint was taken directly from their website. When you're on the OSHA website, there is a link to the OSHA NIOSH Heat Safety Tool smartphone app that's available for the iPhone or Android phone. And I have screenshots on the next slide to show what information is available in using those apps. And another good source of information is the National Integrated Heat Health Information System. And that was jointly developed by CDC and NOAA. And it provides heat forecasts and alerts that you can look up for a specific address or port or area, if there's any heat alerts in place. And it does have a ton of resources available for heat stress prevention and control. And there's a link there for it as well. This is a screenshot of the OSHA web page that shows on the left side. It's probably hard to read, but the OSHA NIOSH Heat Safety Tool smartphone app, and that's where you could go and download that, and it's free. And there's also further down on the page that you can't see here, but there's a lot of links for training materials, wallet cards, handouts, different protective or control methods. So it's highly recommended to visit that website as you're putting your heat illness prevention program together. And this is a screenshot of the iPhone, the app, what information, if you download that app, what you'll have available to you. Going from left to right, it'll show the current heat index. It can give you the hourly index to show you whether the trend is going up or down. First aid provisions for the various types of heat illnesses. Far right, a place where you can enter the temperature and the humidity, and it'll give you the combined heat index based on that. And there's other information available as well. So that's a worthwhile app for those that have an iPhone or an Android that may be interested in downloading that. The NIHHIS website. This is a screenshot of the home page, and I just put in those yellow arrows to show some of the more relevant information for preparing for a given day or for your overall heat illness prevention program. The far left there, heat warnings in your area. You can click on that and put in your, I don't know, I believe it goes by state, county, maybe zip code, and it'll give you a specific notification if there's a heat warning in that area. And on the right, the yellow arrow on the right, the tools and resources, there's a lot of information there. And again, it can be used for planning your training, planning your written prevention program. And the link for that website is also was provided two or three slides back. Continuing on, that concludes the information on heat-related illnesses. Like as I mentioned earlier, for any questions that have been submitted to this point that we have not answered directly, that we will provide an answer within 7 days of the webinar. And again, it'll be on the PA OSHA Consultation Program website. The next few slides just provides a overview of our program. I'm guessing most of the people tuning in today have used our services in the past, but for those that haven't, just to give you a general idea of how the program works. It's designed specifically for small and medium-sized businesses, which to the cutoff typically is 250 employees at a single site or 500 corporate-wide. Priority is given to employers in high hazard industries or if there's highly hazardous operations. And for businesses that are considered larger, we can still do consultations there as well, but generally they're going to be a lower priority and they're going to be limited in scope. Our program is different from enforcement in terms of the fact that there's no citations. It's voluntary, so we don't come in unless we've been requested by the employer. There is an obligation for when we do an on-site consultation for any serious hazards that we may identify or any imminent danger hazards. There is mandatory correction of those hazards, but we do work with you and make it try to provide you cost feasible recommendations, and we provide templates if you need written programs. If you have a training deficiency, we have PowerPoint presentations. We also have some short videos on our website that you can use. So we try to make it as painless as possible, but also as easy to implement the requirements that we identify as needing to be corrected. But and we work with you through the process. So it's generally it's going to be a positive experience if you use our program, and that's the way we try to structure our resources and to make sure that you have means to correct anything that we find that requires corrective action. The only issue that would require direct communication from us to the enforcement side of the house would be if there's refusal to correct a serious hazard or an imminent danger, but those are extremely rare, and it's not something that typically happens, but you have to be aware that that is a requirement on our end if there's failure to correct a serious hazard or an imminent danger that we identify. Our program is free of charge, and the benefits, obviously, avoiding potential OSHA penalties if they were to inspect the company and find things that we would have identified and had you correct prior to an OSHA inspection. Reduce workers' compensation. Ultimately, injury reduction is the goal. And minimize equipment damage and loss of product. Typically, over the course of a year, most consultants find around 7 serious and other than serious hazards per visit. And the savings, when you look at based on current OSHA penalty structure, could save up to $87,000 from a typical visit that we've done. The contact information for our program is on this slide, and our website is there as well, Facebook page, Twitter account. Our next webinar will be July 17th this year, and the topic will be bloodborne pathogens, and that'll be at 10:30 a.m. Thank you for tuning into our presentation today, and I noticed a typo in my webinar. Please ignore that. And any questions, again, we will provide an answer within 7 days if it was a complex question. Thank you.